And so while we're opening to page 15, we'll just have a look at the calendar. The last two classes we have talked about lines. 2 classes ago we talked about lines where you could find a perfect line that hit exactly 2 points or had some properties. Last class we had points that didn't exactly lie on a line, but we found the line of best fit, the line that's closest to hitting those points. And today we talk about other types of equations. Thank you. And that starts on page 15. Okay, so towards the bottom, we're down at number 1. Can we go to Sarah? Bottom of page 15. Taylor?
What do we mean by this?
All right, so first I'm hoping that you guys have a sense that we don't really like the 8 here. What do we like over here? 0. So let's bring that 8 over. We always have the quadratic formula at our disposal, but if we're lucky, then what can we do with this? Factor it. Okay, I'm feeling lucky. Go ahead and try to factor this thing. Agree or disagree with Hazen? Okay, lots of support. That looks good to me. And then once it's factored, then it's a matter of splitting it right down the middle and finding the 2 answers. So either x equals how much over here? 2, or x equals -4. Okay, that is old. There's nothing new in that. We have solved lots of quadratic equations this semester and previous math classes. Okay, so if it looks like x squared plus 2x equals 8, you can handle it. Let's go to the next page. We'll go to Taylor. Okay, so first of all, is it okay to FOIL the y plus 3 squared? Y plus 3, y plus 3, and then FOIL it? And could we distribute the 2? We could, right? I don't want us to do that. I don't want us to feel obligated, like we have to FOIL and we have to distribute every time we see parentheses. I want you to see this. X squared plus 2x equals 8 is the equation we just solved on the last page. Do you see it? It's not x, it's something more complicated. What is it instead of x? It's a y plus 3. It's the same exact equation, but instead of x's, we have y plus 3's. So how are we going to solve it? We're going to solve it the same way we solved that one up there. So we're going to bring the 8 over. Y plus 3 squared plus 2 y plus 3. You know what? Scratch that. I don't want to bring the 8 over at this point. Sorry. I would rather make a substitution first. So let's make that substitution. Sorry about that. Let x equal y plus 3. And this equation becomes, instead of y plus 3 squared, what is it called now? It is now x squared. Plus 2 times, instead of y plus 3, x. Still equals 8. So we substituted so that we could take something that looked unfamiliar and turn it into something that looks familiar, something that we have the tools to solve. So how would you solve this? Well, you would solve it exactly the way we did before. I don't need to write it again. What were the answers? X equals 2 and -4. Those are the answers we got on the last page. Okay, normally when you get x equals, you're done, but x is something we invented for the purposes of this problem. What did we really want to find? We really wanted to find y equals. So all we have to do is go back Instead of x, we put y plus 3. Instead of x, we put y plus 3. So this thing becomes y plus 3 is 2, or y plus 3 is negative 4. Instead of x equals 2 and negative 4, it's now y plus 3 equals 2 and negative 4. That's an important step. It's easy once you see it. But if you don't see it, then speak up. Any questions about that idea of substituting back to the y's? Okay, then how much is y over here? Negative 1. And how much is y here? Negative 7. Those are the two answers. Now, I believe we could have solved this problem with the way we described initially, where you take your y plus 3 and you square it, you take the 2 and you distribute it, you'll have this big mess, kind of combine a lot of like terms, thank you, and eventually get down to some quadratic equation that would factor, and finally you'd get y equals negative 1 and y equals negative 7. So I'm not saying you couldn't do it the other way, but this is a whole lot better than doing it the other way. And doing it this way allows us to do some problems that we couldn't do another way. For example, down here in the bottom, in number 3, take a look at the x squared plus 4x plus 5 squared. If you write two of those things next to each other, okay, the word FOIL doesn't quite apply anymore, but you guys know how to distribute everything in the one parentheses times everything in the other. You know what I'm talking about? X squared plus 4x plus 5. And it's squared, so you don't need to write this because we're definitely not taking this root. But FOIL is really just saying take everybody in the first parentheses and multiply it by everybody in the second parentheses. And then one more, that, and that, and that, right? So we could do that. We would end up with 9 terms. You'd combine a lot of them. The highest term I would see would be x to what power? X to the 4, if you multiply x squared times x squared. I don't know how to solve any equation with x to the 4th in it. I mean, really, like x squared, we have a lot of practice with. X cubed, not so much, and x to the 4th, definitely not. So you could distribute, but I think we'll end up in a place that we don't know how to proceed. So much better is to recognize that there's a pattern happening here. There's something being squared, and then do you see what I want you to see? What's the other thing you're supposed to see in this? We might end up factoring some stuff, yeah? Yeah. It's because the x squared plus 4x plus 5 is there in 2 different spots. It is no coincidence that it's a copy of the same thing. And that's the only reason we're going to be able to solve this problem. And so we'll make our substitution just like Sarah had suggested. But I just want to highlight, this is what we're looking for here, is this kind of pattern. A number times something squared. I don't care what the something is, but the important thing is that it's the same something in the next parentheses. And if you have that, that's what we're calling a generalized quadratic, where this kind of substitution will work. So down here, I'm going to let y equal x squared plus 4x plus 5. This equation becomes, instead of that complicated stuff squared, what is it now? It's now y squared. What's next? Minus 3, and that complicated stuff is still y. And then plus 2 equals 0. Can you guys factor that one? Factor and solve for y. I got y equals 2 and y equals 1. Any questions on that? Factor it, set each piece equal to 0 and solve. But the goal is not y equals, the goal is x, looking at the original problem. So then we do the substituting. That's what we're gonna substitute and get. So we go back, and instead of these y's, we put the stuff that's in yellow because that's exactly what y is. So instead of y equals 2, we have x squared plus 4x plus 5 equals 2. And instead of y equals 1, x squared plus 4x plus 5 equals 1. So what we did there is we said we didn't want to find y. We wanted to find what x was. So instead of y, we put x squared plus 4x plus 5. So those two equations at the bottom, the y becomes replaced with this x squared plus 4x plus 5. First equation and then second equation. Now there's still work to do because these are now two quadratic equations. You have to go through the whole process, make one side equal to 0. I think that they both factor, but to be honest, I would like to stop, pause this problem here and let you finish it later because we've done the new thing from my perspective. So try it later. I think you'll get these answers that are down here at the bottom. But I'll just say ... you need to do quadratic equation stuff to finish those. So what I'm hoping is that you take away from this, if you see some crazy complicated looking things, and if you decide you're going to start distributing through like I had kind of started over here, if you get some really terrible things like x to the fourths and x cubes, probably means there's another technique. And the technique in these problems is a substitution thing. Are there any questions on the pattern? What makes this thing appropriate for this technique? Yeah, Ben. I think that one of these guys is, let's see, maybe it's this one over here. 4. I think this one factors is x minus 2 and or x plus 2 and x plus 2. It's the same, like you just get the same number twice. It's a good question. Okay, number 4, Andy. Okay, so we're going to solve this one, x to the fourth plus x cubed minus 6x squared equals 0. The highest power is x to the fourth. We have hardly any experience with anything higher than 2. So if you see a power higher than 2, it's your indication that there's some special thing happening, and we just have to recognize it. What do you see that's inside of all three of these terms? There's some x's inside of all those terms. And what we want to do is factor out the most x's you can. What's the most x's you can take out of all three? Is x squared. So we'll factor out the x squared. And what's left? X squared plus x minus 6. Is that right? Okay, and I already like it better because I took something with x to the fourths and x to the thirds, and I translated it into a familiar looking quadratic equation. All right, it seems like everything factors today, so let's try our luck with this one. Okay, how much is the x at the far right? X is 2 there. Here, -3. There's one more answer. See if you have not written down a third answer, you've missed one. See if you can find the third answer besides those two numbers. What is the third answer? It's the x squared part. What value of x makes x squared equal to 0? It is 0. It's really, really easy to miss that. You see factors, I'd recommend putting some vertical lines to separate them. And every place you see vertical lines, you're going to have some answers on either side. If you factor out anything with x equals 0 is going to be one of our answers. Any questions on that? Okay, so far we've seen two kinds of like special equations today. We saw this generalized quadratic thing where the pattern was the something squared is exactly the same as the other something. And then this one down here where the pattern is, gosh, those powers are really scary. Let me factor some x's out and bring it back down to size. All right, there's two more patterns I'm after for today. The next one has to do with equations with radicals in them. Let's go ahead and jump to number 6. We'll go to Katrina. All right. So the first thing we might be tempted to do is, how do you get rid of a square root? Is you square it. So maybe the first thing I'm tempted to do is square both sides. Is this allowed? Did I do the same thing on both sides? So is it allowed? It doesn't need to be. We're going to want it to be, but I could square both sides, right? Yeah, and this is kind of the idea. So don't copy this part down, but I just want to show you what happens if you don't do the right thing first. There's x plus radical x squared. I'll go ahead and FOIL this. First is x squared. Outers is an x radical x. Inners is the same thing, so it turns out there's two of those guys. Square root of x times square root of x is what? X. So I get that. X squared plus 2x radical x plus x. Is it better or worse or the same? Well, I had a radical x before. All I've done is introduce a different radical x, but now there's an x sitting in the front. It seems worse than before. So there's nothing wrong with squaring both sides. It's a good intuition. That's what we're going to do to get rid of that square root, but this is not the time to do it. So Taylor says, let's get that radical by itself. We'll go ahead and subtract x from both sides first. So we're left with square root of x equals 12 minus x. Now squaring both sides is a good thing to do. So it's still legal, but the nice thing is that squaring the left-hand side has the desired effect. It just gets rid of the radical. When you do 12 minus x times 12 minus x, please, 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 don't write 144 plus x squared. Yeah, we will. Remember I had said that my health insurance is okay, but it's not good enough for you guys to do this to my heart. So don't do that. If you see something squared, write it twice, and then you'll see to FOIL it. In the middle, I think you'll see there's a minus 24x. Okay, and so I took something that I wasn't familiar with, that square root of x inside of an equation, and I made a new equation with no square root of x. And an added benefit, it's an equation that I know what to do with. It's a quadratic. And so we'll make one side equal to 0 and solve it the normal way. So 0 equals, I'll change the order around so it looks kind of standard. What's 20? Is it 24 or 25 now? It's 25. Yeah, because you got to move that x over. So we end up with one less on this side. Okay, I've been feeling lucky about factoring. Does this one factor? No? Okay, so quadratic formula, or if you have the internet around, then Wolfram Alpha. So somebody tell me, what is it again? You said it didn't factor. Who said it didn't factor? Oh, come on. We'll pretend we didn't see that. We'll pretend we didn't see that. What was it? X, it was 9 and 16? Okay, 9 and 16. I need to learn my factors of 144 better than I know them. But even if you use a quadratic formula, no problem. No problem if you use a quadratic formula. It'll give you 9 and 16. Okay, here's the deal. If you guys remember, we had some equations that I called like rational equations, where there were x's in the bottom. And you could do lots of algebra. We would have to multiply both sides by the LCD of all the denominators, all the fractions. And you might end up with an answer that really doesn't even work. Even if you do everything right, you could end up with this extra answer. Extraneous is like the fancy word for it. So that's true when you have x's in the bottom. It's also true when you have x's inside of a square root. We could have done everything right, and it turns out that one or both of those is not an answer. The only way to know is to check. So you are required to check when you have radical equations. So let's plug in x equals 9. So I have 9 plus the square root of 9 equals, with a question mark, 12. Does it? 9 plus 3, yeah, equals 12. Super. Let's do the other one. X is 16. 16 plus the square root of 16 equals, with a question mark, 12. No. 16 plus 4 is 20. So that means that this guy right here gets rejected. We didn't do anything wrong. All the math is right. Just turns out that with these kinds of equations where there's radicals, you could do all the math right and still end up with an answer that isn't really an answer. And so you're obligated to check all of your answers in these kinds of equations. Derek. Yeah, it's a good point, because if the square root of 16, well, like we call it 4, but doesn't negative 4 also give you the same 16 when you square it? It does. And in fact, that's what the algebra is trying to do. I mean, 16 minus 4, does it equal 12? It does. So like, it's finding the answer if we were allowed to take the square root of 16 and either call it 4 or negative 4. But we can't. That symbol right there is the positive square root of 16. So it's just 4. So it's not some random answer that it's giving us, but still it just doesn't work. Good observation. Okay, so that equation has radicals in it. We've seen how to solve it. The last kind of new equation for today has this funny symbol. What does that symbol mean? Absolute value. Okay, so we'll go to 7 and we'll go to Ben. Let's pause right there. Can you guys tell me a number so that when I take the absolute value of that number, I get 5? 5 works, right? The absolute value of 5 is 5. Are there any other numbers I could stick in there? Negative 5 also works, because the absolute value of negative 5 is also 5. So the solutions to that equation are plus or minus 5. And pretty much that's all that we need to know. If you see the absolute value of something equal to a number, then the something, x in this case, is either the number 5 or negative 5. And so let's try number 8, which is kind of our general rule here. Serge? Okay, so here are the equations we solve. Either the stuff without the absolute value is equal to the number, or the stuff equals negative of the number. Do we buy it? It's like saying x equals 5 or x equals negative 5. And it doesn't matter if it's x or something more complicated, so just call it stuff. So let's try number 9. So we're going to solve 4 times absolute value of 2x plus 1 minus 3 equals 21. Do I have stuff equals a number? Absolute value of stuff equals a number? Not yet. The idea here is that you can't do this kind of funny trick until you get the absolute value by itself. Get the absolute value by itself. And in fact, that's exactly the same thing that worked in the square root equation. Get the square root by itself, then you could do something. So let's get that absolute value by itself first. So we will add 3. And then divide by the 4. And now I have absolute value equals a number. So this thing branches off into 2 pieces. Either 2x plus 1 is 6, or 2x plus 1 is negative 6. Those are the 2 branches. This is how we handle absolute value and make it so that the new equations don't have absolute value. Notice the absolute value disappears when you change it to 6 and minus 6. Are there questions on that? Okay, so we solve. Subtract the 1, divide by the 2. Is it 5 halves? Okay, it's really tempting to put negative 5 halves. You find one answer, you stick it negative in front of it, and you get the other answer. It's tempting, but it's also wrong. You need to solve that other equation, and you're going to see that it's just not symmetric. What do you get when you solve that equation? Negative 7 halves, not negative 5 halves. Negative 7 halves. So it's not as simple as just finding the answer to the regular equation where you just say, oh, it's equal to 6, and you just solve it, and then put a negative in front of your answer. It just doesn't work. You need to get the absolute value by itself, make your 2 branches, and really solve these 2 branches completely separate from each other. Questions on that? Okay, we're going to skip number 10, because I want to make sure you guys have enough time to practice these things on the group activity on the next page. So you will find 4 equations that I want you to solve with each other. We're going to use algebra, not by graphing them on the graphing calculator. And then 1 word problem on the next page, which is really, really, really hard. Let's see if you can do it. I'll walk around and answer questions.